Okay, so let's get going. Hi, everyone. Thanks for joining us today. I'm Paul Baker. I'm channel manager here at Plurilock. Joining me today is our solutions architect, Joel Eng. Joel's got very extensive SIM professional services background, and he's helped many organizations achieve regulatory compliance. And also joining us is our very special guest, Ryan Smith. He's manager of IT cybersecurity at First West Credit Union. He's got over 20 years of experience across defense, government, education, and finance, and he specializes in security operations and incident response. So today we're going to take a look at credential compromise, which is of course the heart of most, if not all, breaches. We'll see some of the tools and techniques that are out there to detect these compromises and what could be done to reduce the risk of them happening. And with that, I'll hand over to Joel and Ryan, and they can take you through the session.
Thanks. So everybody else, my name is Joel, solutions architect here at Plurilock, and I'll start by actually decrypting the title of this presentation, because when we say we want to use your identity as a signal to detect credential compromise, I'm not actually talking about detecting a hacker in the act of using some Mimikatz variant to extract credentials from memory, or using a phishing email to trick a user into visiting some fake SSO page. We actually want to address that messy aftermath in which an attacker, either outside or inside your environment, has valid credentials and for all intents and purposes looks just like an authenticated user going about their business. The background on this presentation is that I've been asked many times why using authentication logs to track lateral movement isn't that effective. And I usually say it's a really long answer. So this is the full answer. And I think some of the people in this audience have actually been customers of my content creation. So guys, this is the full answer to why your rules look the way they do. Also, I should let you guys know, I fully plan on going over my allotted time, but I'm hoping that if you showed up for a technical discussion, you're interested in the very long technical answers. So we'll start by talking about the attack surface. And when I say we're going to talk about the attack surface, we're going to kind of map out what our environments look like so that we have a common framework for understanding where we're actually vulnerable. And then I'm going to move on to what I'm calling the mushy center of our networks. We're going to say what lateral movement looks like there and why we're generally failing to detect that. And after describing the problem, I'm going to present two major architectural frameworks being offered by Azure and AWS for changing the way that we actually do identity access management. The reason we're going to talk about these frameworks is because the underlying theme to this presentation is that actively detecting fully authenticated intruders in a network built on Active Directory has gotten to the point where it's actually so hard, we need to really start thinking about re-architecting our networks in a way that is designed to make them stand out. So one of the good things about doing solutions architecture and working back in sales engineering is that I get to see everybody's networks. And so what we have here is kind of an amalgam of all the networks that I've had the opportunity to work with recently. And over on the left-hand side, that's a user working from home. They actually could be on a managed device or could be on their own device. We're actually seeing kind of a 50-50 split of that. However, almost universally, they're not just remoting directly into an environment. They're actually going through some type of internet gateway. And there's a 99% chance that the internet gateway's identity provider is some type of Microsoft product, whether or not it's Azure Active Directory, AD Connect, or ADFS. Your identity is being verified by some type of Microsoft product that also gives you an SSO session that allows you to get to third-party SaaS solutions. However, most importantly, everybody's logging into VDIs now. I am not a huge fan of Citrix, and I was kind of hoping it would go away. However, the pandemic has breathed new life into it. So overwhelmingly, people are remoting into these desktops and doing their work within the network on some type of virtual setting. Now, once you get into the physical or cloud network, we actually find that these networks don't really look that different. I would say that most people who have gone into the cloud or are doing some type of hybrid setup for the first 5 years simply replicate their existing physical data center up in the cloud. And they look remarkably similar, with the exception being that within the cloud, you actually have this new API layer. And that API layer, it's kind of a hard thing to wrap your mind around at first, that you have these public-facing REST APIs in which a fully authenticated user can manage every single aspect of your environment. The other thing about the cloud environment we're seeing that looks very different is that people usually have lots of different accounts managed underneath a single organization. You can very quickly discover that you can do some logical separation of your assets up in the cloud by putting them in completely separate accounts, which is why almost across the board, we're seeing a dev, test, and prod account. The longer people are in the cloud, the more accounts they have. It usually starts spreading to things like a management account, a backup account, security, DMZ, you name it. And finally, we have our web applications out there kind of doing their own thing. Now, when it comes to credential compromise, the first vector of attack we're all really familiar with is this idea of phished credentials or credentials that are dumped in some other intrusion being reused in your environment, because users often use the same password across multiple applications and organizations. So if somebody has it and you don't have 2FA on your gateway, which to be honest, there are still quite a few organizations out there who don't do this, an authenticated user for all intents and purposes looks just like you getting into your environment, gets a toehold onto a VDI, and then can begin moving laterally from there to anything that that user is currently authorized to get to. The next type of attack that I think we became more familiar with Capital One is the web application compromise, in which an attacker actually compromises a web application, takes the identity of that application or the server that it's running on, and then uses that to move laterally within your environment as well. And finally, the last one that I think is still in the headlines right now is the SolarWinds supply chain attack, where an intruder actually gets dropped into the middle of your environment, starts off on a very sensitive server, and then begins to move laterally from there.
So Joel, would you say kind of the challenge of monitoring identities environments, is it the complexity of the configurations as we scale out and have all these different types of services, or do we think it's more the challenge of monitoring the actual just multiple vectors that come into play here?
I think it's more so on the vector side. So when we talk about monitoring credential compromise at things like your gateway or a web application that takes identity, you have kind of this really small attack surface, or at least a very small channel that attackers have to come through, and you can put very solid workflows there. Whereas when you get into the middle, into that mushy center, there's an infinite number of ways that people can move around. There's a ton of different things that they can do, and so being able to definitively say this is what right looks like versus what wrong looks like becomes much harder once you get into the center. And speaking of the Mushy Center, this is where we're going to start, and I think you can replace Mushy Center with Active Directory, because really we all have Active Directory based environments. If you're using something that's based on the NIST cybersecurity framework, there's a good chance that your network looks like what we're going to describe here. Now, when you first started out, you probably had everything in one big blob of a network, which is why we usually have our user desktops in with our servers. And even when you do get big enough to need to do some type of segmentation, we actually kind of implicitly define production as anything that's not in dev and test. And then anything that remains within production, we actually separate with ACLs. If you are a very highly regulated organization or very security conscious, there's a good chance you're also trying to control the traffic between these users and administrators and the servers on the back end. And most people are actually doing this through some type of bastion host or a PAM solution that allows people to use remote desktop access to get to assets further into the environment. You may or may not be using a different identity to do it, and you may or may not be using 2FA here. However, the actual issue with doing this is that hackers are generally not going to be using remote desktop protocol. They're probably going to use one of these protocols listed here, which are native to all Windows devices now, and in many cases are absolutely necessary for you to actually have a functioning Active Directory environment. And also with the exception of SSH, and in some cases WinRM, when used with the Azure CLI, these things don't actually support 2FA. So with that being said, right here, usually when we're trying to describe what does your identity look like in this environment, what we're actually talking about is just a username and password. And if somebody has your username and password and they get onto a single host, they can generally move laterally between desktops and desktops to servers because we're not actually watching those vectors, or we can't outright block them. The same goes for the opposite direction too, where if someone's dropped onto a server, there's really nothing stopping them from moving from server to server, or in many cases, even server to desktop. Now, if we can't outright block this stuff, which again, that's a very difficult thing to do without breaking your environment, we want to be able to detect this type of lateral movement and be able to say that this is malicious. So what we're going to do next is actually walk through some rule building exercises. And we're going to start by determining what does lateral movement really look like? What type of artifacts does it leave behind? And then what kind of false positives would we run into if we built rules to actually detect this type of activity? But we do want to make sure that whatever we come up with scales, because again, a single rule that one person could use while threat hunting does not necessarily translate to a repeatable process that works across thousands of computers 24/7. So whatever we come up with has to be general enough that it's not going to require a monthly signature update. We don't have to have specialized knowledge of dynamic infrastructure changes. And I'm also going to say we're going to use only Windows events. I know like Sysmon's a fantastic tool. We have EDRs, we have all sorts of things out there for increasing our visibility into this space. But in the words of a friend of mine who actually ended up dealing with the SolarWinds situation, He told me we couldn't install EDR or AV on our SolarWinds server because of the threat that it could actually impact a production system we really needed. So it's, I don't think, a valid assumption to say that we're going to have perfect visibility everywhere, or that just because we're the security team that we get to dictate where security tools go. And in this environment, we're going to say, again, identity is username plus password. So let's figure out, what does credential compromise look like?
So Joel, kind of going back at your diagram there, when we talk about this type of architecture, I think one of the key issues that I see is around what we call point in time detection. And that's what a lot of us are relying on as security professionals. But we're talking SolarWinds and all this other attacks. So actors are using more advanced evasion techniques to bypass things like conditional access, to ACLs, PAMs. Do you agree with that? And and is it making it more mushy because of that?
Oh, absolutely. And like I said, the tools that are out there to address this, like, no, I'm not going to name names. We actually work with some of them. But again, a lot of these PAM tools, they're really, really focused on things like remote desktop protocol and this idea that you can channel everything through that one choke point. But the reality is we can't. If you're doing any type of modern, I would say, systems administration, especially in the cloud, it's probably being done over PowerShell or WMI. And so those things are resistant in many ways to, like you said, conditional access policies, just because they were never actually intended to have those types of policies applied to them. So if you do find yourself in that situation, I would say that you need to understand what lateral movement actually looks like. And I think this is a useful exercise to go through, because I know when I first started out in security, I didn't really have any good concept about what hackers looked like when they actually moved around in the environment. So what we're looking at here is just a series of Windows computers in your environment, and they have credentials stored on them from anybody who's ever interactively logged in. And Windows just does this as part of its features. And so we can expect credentials to be on computers after we've logged on to them. Should you actually get a computer compromised, there's going to be some process that we're running on there that you can basically just call malware. And this thing's going to want to escalate privileges until it can get to the highest level of administration that it can do on an endpoint. And what this thing's going to do is it's actually going to communicate outwards through a command and control server, usually over one of these protocols. And I put question marks there because in some cases they can also use custom protocols to get out. Now, the first command they're probably going to get after they've attained system is to actually extract the credentials that they have there, begin looking around the environment to see what else is around, and then moving laterally. And this process is probably not going to want to expose itself as the malware. So there's a good chance it's going to launch an additional process that is going to take care of that remote session. And that process may or may not be in the context of a user. It may also be system or anything else that malware can get a hold of. However, in that type 3 logon, it is in fact going to have to impersonate an Active Directory user. And the process that it spawns on the remote computer is going to initially run within the context of a user and then reach out to its command and control server. Once it does that, it's going to drop this connection and attempt to elevate to system again. And this essentially gives the intruder 2 persistence points in the environment. They're both reaching back to the same C2 infrastructure. This doesn't necessarily always have to be the case. There are obviously we have computers that don't have internet access. And so in those cases, it can use the same lateral movement over to the next host, but instead establish a connection back to the pivot point. This could be a named pipe. It could be simply like UDP connection. There's an infinite number of ways that it can go here. Just know that it doesn't necessarily have to be persistent chained connections going across. It could be going to a C2 server, but it could also just mix it up. And you're going to see a lot of different use cases here. And the question is, like, what do those connections really look like? Because I think that that's probably actually the best time we have to detect this. But if we're going to talk about that lateral movement, we need to start with PSExec, because the model of creating a connection to a remote server, dropping off some code, executing it, and then having that code create a connection back to you is still the fundamental concept between a lot of lateral movement. So with PSExec, we always start off with an SMB connection, which goes to the admin share and it drops off the PSExec service binary, which is a special kind of binary that can actually be instantiated through a remote procedure call to the service control manager. And what we're going to do is tell it to create a service and start it. And then that service will actually create a named pipe back to us, and it's going to run the command we initially gave it. Now, this actually leaves tons of great evidence all over the place. If you're collecting Windows events, the first thing you're going to see is a process ID, a process was executed. And in this case, you're going to see who did it, and you're going to see exactly which process command line they used to execute psexec. You're also going to see a 4648 event, which is an explicit logon. And the reason this does this is that psexec gives you the option to use other identities. And if you choose to do so, and even if you don't choose to, it's going to tell you who did it, what identity they used, and where they were going. On the other side, you're going to see a 4624 type 3 impersonation event. And this is important because, again, this actually tells you the source network address. So you now know that this was in fact a remote connection and somebody is impersonating you, which is not necessarily a bad thing. We'll talk more about impersonation here in a second. The next thing you're going to see is a 5140 because psexec is connecting to a network share. This is a great event. It tells you who connected, where they came from, and what they connected to. You'll see the service being installed. You're going to see the service being run as you. And then finally, you're going to see psexec execute that final command that you actually told it to do in the first place. So we have a few things here amongst all this information. We have where the person came from, who did it, what they executed, and we have corroborating evidence back on the source computer to ensure that we actually have a very full picture of who did what, which means you can kind of take your pick here in terms of events you want to build a rule on. As a general rule of thumb, I generally try to go with rarer events. And so what I would probably do is go with the 5140 to an admin share. That's not something that happens very often, followed by a service being installed where the user is the same between the two events. And this is a good signature, mainly just because, again, this doesn't actually happen very often. If you do use this kind of rule, there's a very good chance you're only going to detect psexec usage. However, we can't stop there because hackers are pretty smart and they know that we're probably going to be looking exactly for psexec. So once you put this into the hands of hackers, the first thing you should expect is that you're not going to see any events on the source computer because if they fully compromise this and they're about to conduct lateral movement, there's a good chance they're going to disable a lot of your logging. And if you missed that, you're not going to have that corroborating evidence, which isn't necessarily a problem here because they are still going to connect to that network, that admin $ share. They are still going to create the service. And they probably will change the name of everything involved in this. And there's also a chance they may connect to the IPC. However, you can still pretty much use the same rule, even if they don't use a named pipe and they go out to the remote C2 server. This rule is actually still focusing on two very rare events. Again, connecting to a network share on a computer that isn't necessarily a file share or the domain controller doesn't happen that often. And on that same computer, there's also not a very good chance you're going to see a service installed immediately after. Where this gets exponentially harder, and unfortunately, this is where most of your experience is going to lie, is when we start moving on to protocols like WinRM and WMI. The first thing to note here is that we don't have that 5140 event anymore, which was a really important event because it actually did confirm to us without a doubt that this is in fact a remote connection. It's a pretty rare event to see. Now that that's gone, in order to establish that this is actually a remote event, we're going to be relying on that 4624 type 3. However, what you're going to find overwhelmingly with these events, especially if we're talking WMI or WinRM, and you're using Kerberos authentication, is that you're not actually going to get a source network address anymore. And the reason for this, I found out, was in the Windows universe, the source network address was never actually needed in order to authenticate. With protocols like NTLM, Microsoft had a portion in there where you could put it in, but it was always optional. And ironically, they told everybody to move to Kerberos, which doesn't ask for it. And so it's probably not going to end up in these network logs 9 times out of 10. So we have actually reached this point in which things get really difficult because we can no longer say that this was a remote event, which is kind of the basis of lateral movement, right? Knowing that there was a source computer and a destination, all we know is that your identity is being impersonated somewhere else, which again is not necessarily that weird. The other thing that's going to change when we get to WinRM and WMI is that we may not actually see a service executable execute over here. WinRM and WMI can copy over executables. They just have that natively built in. They also have the ability to execute base64 commands on the fly. So nothing ever touches disk, which means even if you had AV over there, there's a good chance it may miss this. Now these base64 encoded commands, that is weird. And before you say like, hey, that's great, I just have to look for base64 encoded commands, ask yourself whether or not you can detect this at scale. Like I said, for human beings, that's very obviously a base64 encoded command. However, if you can't get your EDR on that server, as my friend couldn't, you may have to rely on your SIM. And most SIMs don't actually natively have the ability to look at a string and say, this is definitely base64 encoding. And even if you do have that, you're actually working with the 4688 event and trying to correlate that with a type 3 logon. Those are probably two of the most frequent events you're going to see in the Windows operating system and across your network. When you're building SIM rules, you don't want to choose the most common events and then do kind of open-ended regular expression pattern matching against those. So even if you can do this, this is still kind of a computationally expensive rule. To make matters even more difficult, there's a good likelihood they may not install a service if they're using WinRM and WMI. They don't necessarily need to do that because with that base 64 encoded process, or even if they do it as an executable, they can actually inject into another long living process. And so the one that you see there may only live for a second and then disappear. So with this, you might be wondering, like, is this even a valid signature? Like, can we use this? I would say maybe, and here's why. The 4624 impersonation followed by a process actually being launched is in itself an indicator of actions being done, not just on your behalf, but in your name, which has some subtle differences. Windows actually recommends that if you have an application that needs to impersonate a user, the way that you should do it is the parent process should spawn a thread, and that thread should actually have two security contexts, the parent process and then the person being impersonated. And so when you're generally doing this, especially in a remote session, that's where you get that 4624 type 3, is that there is a thread authenticating you to a domain controller and saying, is this in fact the user? And if it is, I'm going to go do some work on their behalf. However, they usually switch back to their context. What's not as usual is for that process to spawn another process specifically in your name, which is what we're actually seeing here. This is usually indicative of code execution in your name, which is something that does not happen everywhere. Ryan, you look like you maybe had a question about that.
Yeah, I think just a couple of comments there. I think, the first one, when we're trying to look at all these different type of environments and being a SIM engineer in the past and still dabbling a little bit, I think, the traditional approach is generally ripe for false positives. Even some of the out of the box use cases that we see with Sentinel or ArcSight or Logarithm need some significant tuning, which also risks or pushes us to possibility of over tuning and missing some of the alerts. But one of the questions I have is, what is one of the main challenges that we see when leveraging logging around PowerShell? Is it the lackluster, verboseness of the logging, or is it more the advanced techniques that we're starting to see around like encoding, or is it a combination of both that makes it more difficult?
I would say it's both, and I would say it's both, but it is primarily that PowerShell logging is kind of terrible. So we have a few different types of PowerShell logging. The most descriptive is PowerShell transcription logging, which shows you everything that happened. If that's going on there, you're going to see every command that was run. Every module will be expanded, so you can see like line by line what code was passed through the PowerShell engine. But the thing is, it's always in a format that you can never ingest it programmatically and really look at it. There's PowerShell module logging, which does go to the Windows event log system, so you can technically be pulled in, but it's super difficult to make your way through. It's really good if you know something did happen and you're just trying to piece it back together. But I don't know that I've ever actually been able to successfully say there are certain modules I should never see loaded, therefore I'm going to use this as a detection mechanism, which leaves you with a few other events. Like you can see the PowerShell engine started anytime it does start. And I think some of the more advanced techniques you're talking about might be things like PowerPick, for example, where PowerShell DLLs are injected into another process. So you never actually even see PowerShell start. You see something that looks normal and it's executing PowerShell commands under the hood. Like that's not the kind of thing PowerShell will ever tell you happened. The PowerShell engine started, all you know is it happened on this computer. So I would say it's a little mix of both. I don't think it was ever fully intended as a forensics mechanism, which is why it doesn't really serve our purposes for detecting this kind of thing. So I'm not gonna lie, this doesn't leave us with a great rule. The rule I would say we have here is that we have two events, a type 3 logon followed by a process execution event that maybe has some base 64 encoding, and we know that it's the same user between them. Now, again, what this will tell us is that there was some code execution in your name somewhere, which is in itself not actually a terrible signal to go with. But the thing is, we're going to run into some false positives. So in this case, there's two places where you're going to see this happening. The first one is on the computer you're actually logged into. When you log into a computer over here on the left, that's actually pretty normal to see, that there are processes on your computer that you are executing and they're doing work in your name. So you should expect to see this 4624 followed by the 4688. The only thing is, if you were to actually remote into another computer, this is actually the only time you would expect to see this in your name. This means that there is actually code being executed in your name, and it was being done in a way that was past the impersonation that we would normally expect to see. The issue is it's really difficult to tell the difference between these two scenarios because we don't have a good proof of life. How do you know, looking here or here, exactly which server or exactly which computer the user is actually logged into right now? It's easy to say we have a type 2 logon or something that's interactive like a type 10. Maybe you can see them dismissing like a screen lock. But the thing is, try to do this over time. We're talking about scale again. If someone logs in at 8 a.m. and then we have a code execution event at 4 p.m., they probably locked the computer a few times in there. But really, realistically, when you're talking about correlating these types of events, with your sim, you don't really want to go above maybe 10, 15 minutes. Like that's about the max when you start using a ton of memory, it starts getting so computationally expensive that it doesn't make sense to do it. So without proof of life, it's very difficult to tell where the user actually is and where this would be acceptable. The other thing we have is the true source, right? In between all of these events, again, we're not getting that source network address anymore. So you can't really say, was this remote or not? We just know that it's happening. The last one I would say is proof of identity, right? So Ansible, if you use that rule, Ansible is one of the first things I think you're going to see everywhere. They created this module that actually uses WinRM with base64 encoded commands for all the same reasons hackers love it, which is that it doesn't leave behind a lot of evidence. And people use this all over the place now. And so this is a tool that should be doing these types of logons everywhere. And even if you did know what the source network address was and you could trace it everywhere, what proof do you actually have that that's really Ansible? You know, in the SolarWinds attack, service accounts were compromised, and they were like, if they were like any accounts I've dealt with for SolarWinds in the past, they actually had the ability to log in everywhere. So it really wouldn't be weird to see them doing this type of stuff, remoting into computers and executing code. So with those three kind of, I would say, limitations, lack of proof of life, lack of a true source, and lack of proof of identity, seeing an attacker pull off these moves looks exactly like all of these different types of events, which are happening all over our environment all the time. So like I said, in my former life, I was a content developer. I've created a lot of rules around lateral movement in a lot of different places, and I've tried a lot of different things. And Ryan, I know that you've also been a content developer, so I am willing to take some criticism from you on these things. I'm going to talk to you about what these things might, what we were actually going for with these. And Ryan, maybe just tell me about what kind of false positives you would expect to see with these.
Yeah, I think from my perspective, yeah, being there doing the content development as well as when it comes to sim implementations, like I see this concept of like log all the things and build all the rules, where we get super aggressive in what we want to do, but it quickly just leads to burnout of your SOC team because they're just constantly just chasing these herrings around. And the second factor is the continual tuning will eventually become like unmanageable. You're just going to constantly be tuning, and you're going to spend more time tuning your sim than you are actually reacting or threat hunting is what you really want to be doing. And that's the two things I see with this kind of approach.
Yeah, absolutely. And when I've created these rules, I will say this: these do catch things. I think kind of the issue we have though with lateral movement and credential compromise specifically is that we're looking for something that's already fully authorized in our environment. Really, what we're trying to figure out is it really the user behind this action? And so, which is why we always start off with anomaly rules. I think a lot of people go towards this user behavior analytics play where you say, I'm seeing you log into some place you haven't logged in before, or you're logging into a lot of destinations, which is weird because you don't usually do that, or I'm seeing a lot of identities being used from a single source. What type of false positives do you think those would generate? Sorry, Ryan.
Sorry, just coming off on mute. I think it's just a lot of just chasing here when we're dealing with anomaly rules, especially now that we're doing like work from home. I think one that we saw as we quickly scaled up due to COVID is that our staff were logging in from unusual locations. So in the first 2 weeks of COVID hitting and us transitioning to home, our staff were chasing about 40 to 50 of these a day because all of a sudden a staff member that always comes into a physical facility is now logging in from home. And maybe they're moving around and they're using their phone and then they're using their Surface device. And then multiple identities from source. As we spin up VDI solutions and VPN solutions, we start to see now that detecting a lot of false positives where, okay, now we got to do more tuning, we got to add some whitelisting or some allow listing to, ignore rules from one single source, because that's normally a source that we have a lot of people logging in from, and it's difficult. And again, it takes your security operations team off task from when they're supposed to be hunting and finding problems to tuning, which we don't really want them doing.
Yeah. And I would say too, with the authorization rules, that was kind of the answer to it, right? Which is to say, new stuff happens all the time. So let's just focus on what shouldn't happen. In these cases, built rules around things like server to server. So if we have two completely unrelated servers, we probably wouldn't be expecting to see them to talk, with a lot of whitelisting for things like solar winds, which in this case, really would have bitten us in the ass, because obviously that's what was used on purpose. The other one was DMZ to internal, which is kind of this idea of you should never expect to see a session originate in your DMZ and come internal, which is definitely not something you would expect to see. I'll tell you right now, some of the issues I ran into that was I ended up finding out my DMZ wasn't really as well as defined as I thought it was, and that we did in fact have a lot of different ways in which people doing like totally legitimate systems administration were just finding ways around it. They didn't even know they were kind of breaking the rules. And for desktop to desktop, it's a pretty good one, but you definitely need to know who your service desk is, because more often than not, you're going to be catching them before you actually catch anyone else. So I think definitely you hit all the right points, right? The thing with these is, while they will catch things, they kind of catch a lot more than that. And we really, really need to be careful about scaling when we're talking about burning out security operation centers.
Yeah, and around authorization rules, I think the big one too is that we're moving so quickly now that we're standing up servers, and smaller teams can do it a lot better where they can map out traffic rules. But a lot of bigger teams can't do that, especially when you have a networking team, you have a firewall team, you have a security operations team, you have all these different silos that may not necessarily can communicate effectively, and all of a sudden they start sending up new service, and then the team's not chasing these two servers that are connecting. It could be a security scanning server for all we know, and then the desktop to desktop. Most help desks that I know of are a continual revolving door of staff as they come in, get some experience, and they leave. So trying to keep on top of that is really difficult.
Yeah, and so guys, so the first third of this presentation is a little bit of a downer, because what we are essentially saying is Active Directory was never actually set up in such a way that it was designed to stop this kind of thing from happening. Microsoft said the username and the password is the identity. If you have this, for all intents and purposes, this is an open field for you. Here's a bunch of protocols that don't support 2FA. So we are kind of at this point where I would say that Mushy Center, it is an open field, which is why when we go to this next part, we talk about Azure Active Directory and their concept of distributed identity. We're going to talk about how we actually get rid of that Mushy Center, or at least the way that they would like you to do it. And first off, if there's anybody here from Microsoft, I need you to work on your marketing for this solution, because when we were putting this together, I found there's about 10 different names for all the different services you have and the different frameworks that you're putting this under. I'm just going to call it Azure AD for the sake of this. And in this case, they're going after the perimeter, and they're going all out there. And I wouldn't say that they're actually introducing anything new in terms of security concepts. These are things we all might be doing individually, but I guarantee you nobody's doing them all at once in a single package solution. And with this, what they're actually saying is, instead of saying that your identity is a username and a password, it has to start off as multi-factor authentication. So that's the bare minimum for getting in. But then we also have a profile, which is a description of what you look like and what your computer looks like when you actually approach the network to authenticate. And there's also something that I would call a posture. A posture is essentially like a risk assessment of you and your computer, which is to say, are you in the correct risk state for me to allow you through, even if you're you? So credential compromise becomes kind of a very complicated policy decision, where you're saying, I'm seeing a deviation from your profile or from your posture, followed by a failure in the user's part to perform MFA. So Microsoft really wants you to go to a zero trust network model. And I would say that their concept of what they're doing for credential compromise works best with zero trust. It kind of gets rid of that mushy center altogether. And a zero trust model in its most extreme form, it looks like a completely flat but micro-segmented network that's technically accessible from anywhere, because every single connection is treated as completely untrusted. And in order to connect, you have to go through this super heavy-duty gateway where there's Azure Active Directory, and your primary form of authentication is going to be passwordless MFA, which is not to say that there's no passwords. It's just saying that your password is now kind of a secondary form of authentication where your primary is actually a biometric coupled with something you have that unlocks a private key. And this private key is used to encrypt a challenge response back to the gateway, which it uses your public key to decrypt. And this doesn't sound that complicated. Like I actually used Microsoft Authenticator this morning, but I'd say like, let's take a second to think about how elegant this solution is and how many different security problems it actually solves. For starters, we've always known, we've chosen passwords over biometrics a long time ago because we started saying things like you can change your password, but you can't change your thumbprint. But really the issue was that we were sending your thumbprint across the network and saying, this is who this person is. So in this case, it doesn't really matter who has your fingerprint. They can't unlock your phone because they don't have your phone. So tying your fingerprint to something that you own actually makes that a much more secure transaction. And the thing with private keys is while we know that they're actually super secure, the issue with private keys is you can lose them or you can share them. In this case, if it's locked on your phone within the Authenticator app, and that can only be opened by your thumbprint, that's a pretty clear indicator that whoever actually decrypted this response and encrypted it with a private key was in fact the person behind the identity. But we're not going to stop there. There's also this idea of just because you have the right credentials doesn't necessarily mean you can come in. In this case, there's something called conditional access policies and identity protection, which are technically two different services, but they do work together. Now, on the left-hand side, conditional access allows you to do things like just specify in plain English conditions in which you would let somebody in, but be incredibly granular about it. So, for example, you might say, yes, you have the correct credentials, but I don't like the computer you're on. I want you on a Windows device, or I want you on a managed device. You can also look at things like the state to say, you're missing a couple of agents, so I can't let you in. Or I don't like the location you're at. I don't want you to access this place from Starbucks. Or maybe I'm going to accept that, but I'll accept less risk. So I'll only give you applications that don't contain a lot of sensitive information. Or looking at the user's group, say, all of this stuff is correct, but you're also an administrator, so I can't let you in unless you're in the corporate footprint. And the last two pieces of it, I think, are actually probably some of the most exciting. Sign-in risk and user risk. Everything on the right-hand side is what I would call their identity protection platform. And this is just some of the different rules that they actually use to analyze your sign-in and the user posture when you're logging in. So you could say this is a lot like if you had your threat intelligence team embedded with your identity access management team, and they were looking at every single logon to give you a risk assessment of it. So when you're signing in, they could say, hey, look, Joel was in Chicago. Now I'm seeing his credentials being used in South America. I think that's too risky. So even though everything else is fine, we're not letting him in. Or you could say, it's definitely Joel. Like he's in the right place, right computer, right posture. However, we also found out that his credentials were leaked. We got that intelligent through a threat intelligence platform, and we can't let him in until he changes his password. So this is, again, everything we've been doing, but kind of in a really automated, nice, centralized solution. And I think Microsoft also recognizes that just because you're you when you first log in, that doesn't mean it's always going to be you for the entire session. I mean, really, compromise happens to fully authenticated users. So they have this concept of token timeout, which is something we're very used to. The thing with token timeout, though, is that the shorter the time frame for token timeout, the worse the user experience. And the longer that we actually make it, the more risk we take on. So they created this thing called continuous access evaluation, which actually injects events into your authentication stream. So for example, let's say you have a second session open up and it has a different IP. In this case, they would actually send a challenge to the user to say, show me with your MFA that this is actually you. But it could also be something benign as well. Like you just changed your password. They would send you an additional MFA prompt because even though you have a token that's technically valid for another day, it was based on an old password. And so they want you to have the new one. I think one of the more exciting things about this that is not super fleshed out just yet, but I think has a lot of potential is this concept of just-in-time access. So with just-in-time access, your VDI that you actually log into can actually have a different security group until somebody actually requests access to it. So essentially, it's in this contained space that can't be reached until a fully authenticated user wants to log in which case its security posture actually changes to allow you on. And it's not just that you can get onto VDIs this way, this also goes for other resources you request. So for example, if you want access to that database, I might give it to you for 1 day. And over the course of that day, you can do your work there. And at the end, when you log out, that permission now gets removed from your identity. So even if you did manage to compromise your VDI, it doesn't matter, because whoever logs in, when they pull your credentials and they attempt to use them, they may or may not even be able to get off that computer in the first place, because the actual network security group for it has changed. And even if they do, they may not actually have access to all the resources they want because you are not logged in. Now, there's a lot of features to this, and I think it's a very complete solution. I think it addresses a lot of the different problems that we've all talked about. It's really easy to understand, and I think it actually simplifies things for users as a whole. The cons on this are that it's really expensive. And Ryan, you don't have to give us an exact number, but I have heard that this is upwards of like $40 a user per month. Maybe just nod north south if I'm in the right zone there. It's expensive, and also too, it's incompatible with anything you can't put behind Azure AD. And I think honestly, the weakest part of it though is it relies on the user, because if you do put a button in front of a user and you say, I'm not going to let you do what you want until you press this thing, there's a good chance they're going to press it. Now, Ryan, I know you have a ton of experience with this. Is there anything else you can add to Microsoft's Azure AD experience?
Yeah, so like, yeah, big fan of Azure security and all their stuff. But when it comes to zero trust with Microsoft, you almost have to be all in, to be honest with you, which is expensive. And to kind of get the best out of the technology, you have to have that diamond studded E5 license edition that you can get. And yeah, continual monitoring is still a bit of a weakness within the environment. But what it has forced us to do in a lot of organizations is you have to now shift focus around security back to the user again. So what we have seen, and I've seen this in multiple different instances throughout the credit union system in Canada, is conditional access. We're seeing a lot of our threat actors shift to, using geographic locations through botnets. They'll do a botnet as a higher service to actually attack different organizations based on their intelligence. So if they know that an organization is based in Vancouver, they will likely rent a service that's based out of Vancouver. So when a user gets a challenge, on their phone, which I got one this morning, it's going to say, hey, you attempted to log in from Vancouver. Do you accept this? And, majority of the time, our users are always going to click yes, because yeah, I'm in Vancouver. I'm going to click the yes button. So now we're really having to train our staff to say, hey, if you get these really odd requests, if you get a bunch of requests in the middle of the night, if you get one just randomly as you're working in Outlook, you may want to double check and take a look at that a little bit more. So it's forcing, again, some more fringe use cases, and it's changing a little bit of focus there for our users when it comes to distributed identity in Azure.
Cool. Well, that was Azure. Let's talk about AWS, because I think Amazon's approach is a little bit different. It's influenced by their status as, I think, the dominant cloud provider, which is why it's actually focused entirely on customer-facing software and cloud infrastructure. I think this is one of the coolest things that happened in cloud infrastructure in a long time. AWS is taking a fundamentally new approach to security. It doesn't just reshape your attack surface or try to minimize human errors. We're going to remove the attack surface altogether with the AWS well-architected framework. And AWS is redefining identity as a configuration that is dependent on your environment. And credential compromise is simply defined as any deny in production. So this is going to sound crazy. I would say it has 3 legs to it. Each one of them sounds a little bit crazier from a security perspective when you hear it, but when you put all 3 together, it makes a lot of sense. So the first one is something called attribute-based access control. And I think if you're in security, this is going to make you very uncomfortable, because it's a complete inversion of the idea of least privilege and role-based access control, where you start users off with minimal privileges and you only give them what they need to accomplish a role. In this case, though, Amazon's saying, give them everything. And so the question is, how do you control somebody who starts off with all the permissions and only gets things taken away if you can make a case for taking it away from them? Amazon's solution is this idea that you can do whatever you want to things that you own, except escalate privileges. And so let's actually deconstruct that and figure out what that would look like from an Amazon perspective. When I say you can do anything you want, that does in fact mean that you as a user have wide access to create, modify, update, and delete anything within the AWS services. However, you can only do this to things you own. Now, what that means is there's something called a permissions boundary. And when you put a permissions boundary on a user, it has a requirement that every time you create something, it gets an attribute in the form of a tag that says you are the owner. And because you are the owner, now nobody else can touch it, but vice versa, you can't touch other people's things, which means that there are other users who can live right next to you in the same account, and they can do whatever they want, but we can't touch each other's workloads. I would say you probably still don't want these going on like inside your production environment, because even though we can't touch each other's work, our work can touch things in production. So what if you could put them in another account? And I think I mentioned to you guys, you can have lots of different AWS accounts. In this case, you don't necessarily have to have them in the same account as your production assets, which is something, again, we still generally do with users. Instead, production is looked at as this read-only environment that is completely separate from where users actually do their development work. And so this idea of having users in this environment who are extremely privileged becomes more palatable when you accept that they can't actually touch anything important. It actually becomes even more palatable when you consider that nothing they do there lives. So essentially, there's no persistence in this environment. Users can't touch each other's work, and they can't touch production. Still crazy. You're probably asking, though, how do you actually save your work there? And how do you really modify production? Because the reality is, the only reason we have jobs is because we modify production. In terms of saving our work, you actually have to use something called infrastructure as code. And if you're familiar with CloudFormation or Terraform, these are declarative languages that allow you to use things like JSON files or YAML files to describe workloads. And workloads are groups of resources that come together to perform a business outcome, which it sounds generic, but basically, if I was a SIM administrator, I would now be in charge of a file. And that file would describe my servers, my databases, the API gateway that users use to actually reach the servers, probably the load balancer that people use to send data to the SIM, as well as the actual users that the computers use to interface with the AWS environment. So everything about my job is now encapsulated in a single file. And it's because it's all within the same workload, all of those things can talk to each other. They're all owned by me, and other people cannot touch my workload. This also gives us the ability to do something coders have been doing for over a decade now, which is user revision control. So you can actually definitively see what changes did this person make to this workload when they do it. And you can actually see it before they make the changes, because you have to make the changes to the code first. So to put this all together, you have something called immutable production. And in this case, remember, I was the king of my little world over in the dev zone. But when I come to production and I actually want to affect change there, the only permission that I actually have is the ability to submit a workload in the form as code to a DevOps pipeline. And it's actually this pipeline that gets to approve the change and actually produce it. So in this case, when I submit my workload to code commit, we're achieving something called change fidelity, which is the ability to actually say, this is exactly what changes Joel is going to make. Forget about what he said in the change approval meeting. This is what his work is really going to do to production. This also leaves it an immutable, I would say, record behind of exactly what was changed. So there's no saying like, hey, I didn't make that change, or I didn't intend to make that. It's definitely in the record. After you get through code commit, it goes to what's called code build. And in code build, this is where other stakeholders get a chance to actually assess your work and either kick it back to you, ask for changes, or just completely reject it. So in this case, a systems team could tell you the server you're using is far too expensive, don't use it. Identity access management could say, I need you to deprivilege your users and more tightly define what they're able to do. And the security team could say things like, I need you to patch the software you're using, or I need you to tighten up your security groups because you're accepting traffic from everywhere. And it's only after these teams actually approve your work that it goes to the only entity in the organization that can actually affect change, which is code deploy. So code deploy actually only has a couple of things it can do. It can take infrastructure as code and instantiate workloads. And when it instantiates one workload, it gets rid of the old workload, which gives you something called change resilience. Because let's say the new change you want to make doesn't work. All you have to do is roll it back and reinstantiate the old workload. And once these things get into production, nobody can touch them. They're essentially in a read-only status. So no users have the ability to touch this any longer. But they do send back telemetry that you use to monitor them. And if you need to make changes, you actually push it back through the process. So to kind of wrap your mind around this, consider that this is now taking privileges away from users altogether and putting them into a process. And so if you wanted to compromise this production, you have to compromise either all the users or the entire process. And to get a better idea of what this looks like, let's look at Capital One, because in this particular breach, this was an AWS hosted service that was compromised. This attacker managed to find a WAF with a server-side request forgery vulnerability. She used that to actually act as the EC2 instance and request a token associated with the instance profile, which is essentially an identity attached to that server. When she got back that access token, she found that it was actually privileged, way over privileged, and allowed to access all S3 buckets. And so she was allowed to actually download everything she could find and then take it out from basically from outside the network. If this was using well-architected framework, a few things would have been different. For example, the S3 bucket associated with this WAF would have been defined within that workload. And so the scope of the permissions of that access token would have been limited specifically to that S3 bucket. Now, you could say, yeah, that's containing blast radius, but it's not really preventing anything. It's not really detecting anything, because technically with that access token, you're authorized to read it. However, down here at the left, I would also add deny the ability to list anything to identities within this workload. Because in theory, if you are a part of this workload, you already know what all the team members, you already know your team members. You know the name of every single asset in there. So you should never have to ask AWS to show you the name of what you can access. So there's simply the act of a human being asking, what can I actually get to, and can I read it, would in fact expose this token as being compromised. This is, I mean, let it all sink in. But I think what's really cool about this is what it means in terms of like compromised credentials. It doesn't really matter if you actually have my credentials. It doesn't matter if you have this access token, because you can't use it as a human being. You don't know what resources this has access to, and simply the act of finding out what resources it does is going to expose you. So identity now becomes this configuration that is context specific and doesn't work outside of the area that it was actually intended to work in.
This is one thing that it's one thing I really love about the well-architected framework is, a couple key areas is, around the over-provisioning of permissions within AWS. Like that seems to be the #1 problem every time we hear about something compromised in that environment. It's over-provisioning. And the second one is the technology is really driving the structure of security teams here with this architecture. And now I'll start to talk about DevSecOps. This is where this fits in really super well to help organizations, get stuff to deployment faster. Because the issue that I see with it, and that a lot of my other cohorts see with it, is if we don't change the fundamental ways that we operate security within this environment, using the well-architected framework with the technology that you have will slow production down. But if you think about it differently, embed security in your teams with DevSecOps, that'll actually increase the cost or the speed of distribution and deployment, and overall security across the board.
Absolutely, I think you called it there. Like I said, in terms of pros and cons, this is DevSecOps essentially, and it really simplifies the concept of credential compromise. However, this is really difficult to pull off, and I would say that if you're doing this, you're probably Netflix, and we're all trying to catch up to what they're doing, because it does require a lot of organizational change. There's the potential for like exponential cost overruns, because if you give people the perception of infinite supply, they will infinite demand. And so you could have a lot of people creating 100 different servers if they're allowed to. And also, this is not really applicable for long-running legacy infrastructure. And when I say legacy, I mean, I use the example of a SIM, but even a SIM wouldn't be a good thing to do with this, because we're putting all the configurations within the application itself. And so deploying those changes through this framework probably wouldn't work that well. Now, I'm going to jump ahead real quick because I know we're running out of time. And we're going to talk about Plurilock's solution to this. We are not solving the entire Mushy Center, but we're saying don't give up on it. There is a point of compromise where these things usually start, and that's where we are focused right now. And we intend to cover the entire Mushy Center. We start off with identity essentially we call it a behavioral biometric. Instead of looking at a point in time authentication, instead of applying tons of different rules to it or trying to constrain it, we're just saying that your behavior is the way you act, but it's not necessarily the way you act on a network. We're looking at the way you type on a keyboard and the way you move a mouse, which is not to say we actually look at what you type or what you click on. There's simply a way that you move your hands that you're not even conscious of that allows us to identify you, continuously as you're using the computer. And so credential compromise becomes a human being other than you using your credentials. And so we'll do a quick demo here with Paul. Pull this over.
And maybe as you're setting that up, Joel, comment around biometrics. When I think of some of the behavior biometrics, when I think of some of the recent attacks the actors have been in the organizations already, even with that organization having significant investment in security. I think SolarWinds is a great example of it. But significant indications that the majority of these attacks are likely automated to start. Say they get in, they get persistence, but they involve like significant human operation. At the time that they're trying to actually get the data out and actually maintain or get to their objective. So and they've already, by the point of that human operation, they've already bypassed a lot of the significant portions of their defenses, and that's why this is super key.
Absolutely, and that's really what we're going at after here is, what do you do when someone's hands on keyboard? And what we're looking at here is Plurilock defends continuous authentication logs. And so in this case, what this is doing is this is watching me, and it's measuring every couple of seconds when I actually interact with my computer, which is something you have to do in order to get into the environment. And it's taking a look at what application I'm using. And in this case, it's comparing my keystrokes to a machine learning profile that it's built for me. And it's saying, in this case, this is a 100% match for me. And because everything I'm doing right now more or less matches the way I normally move my hands, this is saying that my risk level is completely normal. And in real time, it can monitor you. It doesn't really matter, again, what application you're using. What I kind of like about it is that it doesn't really matter if you're doing it correctly or not. All that matters is that, again, you are interacting with the keyboard, and it is me or it's not me. And so in this case, what I'm doing is I'm just interrogating a Splunk agent, which is something I used to do on a day-to-day basis. What this is actually going to say is, this saw me actually using the command line. In this case, this is 91% sure that it's me. But let's actually just show you guys, what does it look like when it's not me? And what type of risk score do you see popping up? So Paul, would you mind taking over real quick and just controlling my computer?
Sure.
Get that out of the way. Okay, you're in charge.
Where's your command prompt gone?
There you go. So what Paul's going to do is he's just going to enter a few commands that someone might do if they're, again, like Ryan said, going hands-on keyboard with my computer. Like if someone had stolen my credentials, they got to the front door, they're on my keyboard, or not necessarily on my keyboard, but they are remoting into maybe my VDI, and they're taking over. They would probably want to know who I am, what I can do, what state is my computer in, and is there an avenue of approach for privilege escalation? And what Defend is doing right now is you can see it escalating my risk level. What this is saying is, Paul doesn't type anything like me, but it knows that just a couple of seconds ago, that was definitely me typing into this application. So it's not necessarily immediately going to go into a high risk state. It needs to see some activity over time before it says, this isn't Joel just having like a blurb. He didn't just have too much coffee. This is in fact not Joel on the computer. And it happens in real time. It happens very quick. And again, it doesn't actually matter what application we're on. So you notice Paul's got himself to a medium risk state, and now he's into a high state. So once you actually get to a high state, a few things can happen. In this case, Defend actually does have the ability to do some type of SOAR capability where it could lock out the computer if you wanted to. More likely than not, though, if you're working in a SOC, you don't want to take that kind of risk with your users. So what you're probably going to be able to say is like, I want this thing to stay in a high risk state unless this person acts just like Joel, or I come through and I deem this a false positive. But what we're actually going to show you right after this is that we're going to take this data and feed it into a SIM, because I love SIM, and also in most security operation centers, we are actually having all of our sensors feed their data into the SIM so that we can evaluate it there for further action. And in this case, thanks, Paul. I think we're good here.
Alrighty.
You'll notice that this is what credential compromise looks like in our environment. It's simply an escalation of risk. And this risk is really not necessarily that Paul was doing anything wrong. Every single thing that he did was technically authorized. I was actually using the exact same application, but in this case, it just wasn't me using the keyboard. So the first thing you probably want to do on this is actually alert on it. We created an alert. It just says if you see 4 high risk events over an hour for a single user, for a single application, that's probably a good indicator that this user may or may not be compromised. And so if you use this as your base alert, you probably also want to know a little bit more information about what was this user doing around this time. I would probably give this to one of my junior analysts. And so to be honest with you, like that's just how SOCs work. And that junior analyst would probably want to know, what are the left and right limits of this investigation? Where should I start? Where should it end? And in that case, this is a pretty good indicator here if you're just graphing risk over time of when should you focus your investigation. This is when Paul was in charge of my computer. And I'm just going to jump to this next feature because I think for those of us who actually work in incident response, this is a key feature. This thing tracks the actual application that you're really using. So when you're looking at just raw forensics data, it can be very difficult to tell what was the human's intent and based on what I'm seeing in these records. This, however, actually does track what applications or your keystrokes are going to, what you're actually clicking, which applications your mouse clicks are going to, without actually capturing the ASCII characters themselves. So in this case, what you can actually see is that these are the applications Joel was really using. If you want to know exactly how much we're using it, it's also here too. How often do I play Call of Duty? Quite a bit. However, that doesn't just have to end there. If you actually know what application I'm using at any given time, and you can assign it a risk level, it allows you to clean up this mess, which is essentially these are just raw Windows events. And if you gave this to somebody and said, tell me what Joel did, my name's technically on every single one of these things, but I mean, how confident are you that this was really me doing it? If you combine our defend data with raw Windows data, and you say, show me only things that I know for a fact Joel was interactively doing, and then assign them all risk levels, it allows you to get a picture like this really quickly, where you can see this was Joel using the command line. This was definitely him. And then suddenly his risk started going up. And then somebody else took over the computer. And at this point, it went to a high risk state. So this allows you to clear out that garbage really quickly and actually focus on what really happened. And again, it's all just related to the fact that Paul's pattern of typing doesn't match mine. So Ryan, do you have any questions about that? Like anything fielded from potentially Q&A?
No, it looks really good. Like I say, we tested it before in the past, and for me, it helps alleviate some of that risk of that user clicks on accept for the MFA, they get in, and then now you have say hands-on keyboard attack, and it's like that extra sensor that we can see at the network.
Exactly. Yeah, and that's really where we are. It's a sensor that says, instead of just allowing access to credentials, now we're actually evaluating the user themselves and the way that they behave on a micro level that they can't possibly be aware of, something that they don't see, and something that actually can't be faked. So thank you very much, everyone, for attending. That is all I've got. I really appreciate you guys coming up. And thank you very much, Ryan, for acting as our moderator here. Paul, I'll let you take it away.
Thanks, Joel. Yeah, thanks to everyone that came on. I hope you found this session very useful, very informative. I know I learned a whole bunch of stuff that I didn't know, so that's always a good use of time. If you want to take a look at any of Plurilock's products or chat about the challenges that you face and how we can help you, please don't hesitate to reach out to us. Thanks again, Ryan. Awesome having you on here. Joel, fantastic job. Thank you. And thanks to everyone that came along.
Thanks a lot.
Thanks. Everybody.